All right, so this is the AP test prep review for all those people for calculus. Yay.
Yay.
Okay, and there was someone supposed to be here already with snacks. Yes, I'm calling you out. You know who you are. All right, okay, so we all have this packet. So what we're talking about here is we're going through and talking about what a limit is. So a lot of things that we're going to go back over is stuff that we've already done. So what we're going to do is have an approach that is explicitly AP. So like how to read it like an AP question. So in order to understand a limit, you need to know what a limit is. Limit is the value of a function, which is usually written as f of x on the AP exam as approaches a variable with a function, usually x, gets near to a particular value. In other words, x is very close to a certain number. What is f of x very close to? So it's not always saying that it's going to be that number. It's saying it's what is it going to. Because a lot of times when we do limits, there's a hole. There's something in which that I cannot like put a function there and say it is not equal or it is undefined at that value. But what we're going to look at is right here. So one way of writing it is, why does this keep doing it? Anyway, all right, so limit as f of x is x approaches to 2. So what we are doing is basically evaluating for a function. So this is just the algebra portion. This is all algebra stuff here. So when we start plugging in and we're getting closer and closer to some number, so just by looking at this, we're looking here. So this right here, so when we evaluate at 1.9, it's basically 3.61. Okay, and then if we get closer, 1.99, I don't like violet or magenta. I don't like that one. Oh, it's not working for me. Okay. There we go. Okay. So it's 3.961, 1.999. Okay, and if you notice, as I keep getting closer and closer, as x is approaching the 2, so it's getting close and close. So this is a algebraic way of evaluating what we're having. So as it's getting approaching to 2, it's coming up. You guys can see that it is approaching the number 4. But for a lot of these cases, that it's not going to be equal to. It can't be equal to 4 because it'd be undefined at 2 for whatever reason. So we're finding it as it's coming super, super close to it. So this one right here, gets closer to 4, called the left-hand limit, because these all numbers are from the left-hand side of the number 2. So if I had a number line and I had the number 2, here is my 1, and then we had the 1.9, and we get way over here it's 1.9999. So getting really close to that. So that's from the left side of the number line. And then the right side, so the notation for that would be the limit as x approaches 2 from the left. The minus sign is the left, because if you think about a number line, you read from left to right. The numbers on the left are smaller, the numbers on the right are bigger. So that's how it goes. So reading it from left, it's coming up to that number. But now if we're doing it from the other side, if we look at 2.1, it's going to be from the right-hand side now. We get 4.11, 2.00 or 01. So as we keep getting closer and closer, my pen's not aligned. All right, so now at 2.001, that's super close to 2, but that's on the right-hand side now. And so we come up with 4.004. And so this one is getting super close to the number 4. So the left hand, so from the left-hand side, it goes to 4. And from the right-hand side, it also goes to 4. So for this principle to work out as it's approaching the number 2 right here, left hand and right hand are both going to the same number. So when they both go to the same number, I can say that this limit does exist. The limit exists, and it is 4. So right now, if you notice, we don't have a function we're dealing with. We just have some table with some numbers that we're plugging in. All right, so we didn't really need to look at all these decimals values to know what was going to happen when x gets really close, but it's important to go through the exercise. Typically, answers get a lot more complicated. So when we get into some weirder ones, right here, so find the limit as x squared approaches 5, as x approaches 5. So we could actually plug that in. So if we plug it in for this, we're going to go, okay, basically it's going to be 5 squared. So that's what I'm doing. So it's the limit as x approaches 5. We can just plug it in. There is no place in which that this is going to have a undefined or where it is not evaluated. Oh, you got one? Okay. So we could just plug in, and these ones you could just evaluate, and it's simple. These are simple to evaluate. So we get 25, do the same thing for 3, x to the third is 27. So basically, whenever we could just plug in, where k could be some constant, like let's say there's like a number in front of it. You could factor out that constant number, find the number, okay, like this where it is the limit as 3x squared as x approaches 5. This is actually important for later on because when we're going to get into some weird stuff, that 3 you want to take out to make the math a whole lot easier. But we're not at the weird stuff yet. So it's 3 times the limit, so it's going to be the 75. Okay, let's take a look at the next ones. Okay, so now we could also break this up into the limit as x approaches 5. And so if there is a plus sign in here, that means we could actually separate it into separate limits. We could do this piece by itself, do this piece by itself, and then add them together. So in this case right here where we have limit as x squared, right, as x approaches 5, I just evaluate it for this, so it's going to be 5 squared, which is 25, plus the limit as x cubed, right here, this separate piece right here, so it's 5 to the third power, which is 125, and I could just add my two limits together. So that is going to save you a lot of bacon later on when we get into the AP testing stuff. So during the actual AP test, the actual test. So I have it over here on my wall. Part A, 30 questions, 60 minutes. So if you do the math on it, it's basically 2 minutes per question. Some of the questions are not 2-minute questions though. So when you're looking at it and you could actually try and solve it by factoring out or simplifying it first, it's going to save you a lot of time later on. So 2 minutes per question should be very, very workable, especially if you have any of the multiple choice. Okay, so now let's go on to the next part right here. So this is the addition, and the next one is going to be the product. So it's going to be the product of 2. So it's the multiplication of 2 separate limits. So in this case right here, this is a multiplication. That is a multiplication right there. So I would take the limit, so evaluate it here. So there is a restriction in this one, but not at the number I'm looking for. Okay, so this looks big and complicated right now, but it's not that complicated if you break it up into 2 separate parts. So this part right here, so the limit as x approaches 5, so 5 squared plus 1 is 26, right? So it's 26, so that's this limit. Now let's do this limit right here. So limit as x approaches 5, so it's going to be 5 minus 1 is 4, square root of 4 gives me 2. So the whole thing comes out into 2 separate limits and then my answers I'm just going to multiply together. So we're going to end up getting a 52. All right, so I'm kind of chugging through this. Anyone have questions of the limit stuff that we've gone through so far? No? Okay. All right, so now for this one right here, find the limit, you plug in, we have 0. So 0 plus 0 is 0. Okay, all right, we have 0 there. That's good. So it is possible to get 0 for this. But for this next one right here, we can't plug in 0. We can't plug in 0 because we're looking for a value as it's going to work out. So if we can't plug in 0, that means at this point it's going to be undefined. And that's the issue I'm working with. So I'm working with an undefined, so I can't just plug straight in. So I need to think about it. What's it going to happen on the left-hand side? And then what's going to happen on the right-hand side? So if we go through and graph this, from the right-hand side, if I square it, so think of the number close to 0, but on the left-hand side. What would I have? Yeah, negative 0.001, or what also works is just like a negative 0.1. Okay, if you don't have access to a calculator on this problem, I wouldn't actually go more than just 1 decimal point. So I would look at it and say, all right, so if I'm plugging in 1 over negative 0.1, that's squared. So that's the left-hand side, but now on the right-hand side, it would be the same thing, right? But it would be a positive. So it would be 1 over positive 0.1 squared. So whenever I square that negative, that's going to be a positive, right? And that's going to be maybe. And then 1, 2. So it's going to be 1, 2. So it's going to be 0.01. Yeah, it's been a while, right? Yeah. No, it's fine. Trust me. It's one of those things. I still have to do it all the time too. But like I said, I always am trying to show my work. And mathematically, that made me a better math person. Showing my work, showing everything that I do, it actually makes me better so I can look at what I'm doing. And if I try and cram it in and all my homework looks like scratch paper, it's not very good. Yes, you might get to the answer, but it's not going to help you if you didn't get the right answer. Then you can't go back and say, hey, what was my process here? Or what did I do wrong on this? And that's part of the thing that you actually do. A lot of the stuff that you're going to get, you guys are going to get questions that are like that said, all right, there was a mistake here, look through this. What was the mistake that they made? All right, so for right here, this is going up to a positive. My graph goes here, graph goes here. So these ones right here, I would say it's going up to positive infinity, right? Now, does the limit exist?
No.
No. That's very good. The limit does not exist. Is infinity a number? No. Infinity is not a number, it's an idea. So if it's going up to infinity, I could say the limit does not exist. So as an abbreviation, you could actually say this: the limit does not exist for this. But as behavior, you would say it goes up to infinity, right? Positive infinity on the left, positive infinity on the right. Okay? So here's another one. Right here, we get 1 over x. Now on this one right here, since I don't have that square that is going to make all negatives positive, that means that when I do the same thing on this, it's going to be 1 over negative 0.1, and the other side is 1 over positive 0.1. So now a positive over negative gives me a negative. So now on my graph, it's going to look something like this. So negatives would be right here. It's going to look, oh, come on now, come on, you can do it. Right here. And the positive side is going to go up this way. Now, again, the limit does not exist. The right side is going to positive infinity. The left side is going to negative infinity. Again, the limit does not exist. All right, here's the graph. Oh, wow, okay. Okay, so here's your rules to go along with this. So you guys could actually use this as reference later on as you need to. Bunch of different rules from positives and negatives for this. And then I believe this next part, what we got? Oh, not yet. All right, so now, yeah, we got a couple more examples. All right, so now for this one right here, the limit is going to infinity. Now, again, infinity, we're talking about end behavior. This is what has happened as it's going to a infinite number. So as it keeps going on forever, it's eventually going to approach something. So for this one right here, as x approaches 1 over infinity, now we think about it, 1 over 1 is 1. 1 over 2, if you notice it keeps getting 1 over 4, 1 over 8, 1 over 16. You notice as I go to the right hand side and I keep putting more numbers in, so my x values, right, keep getting bigger, yes? So when the denominator is growing, that means I'm dividing it up into more and more smaller pieces. So the smaller and smaller and smaller and smaller pieces that I'm going to end up getting, that this is going to end up becoming 0. So it's like, you know, we got person brought in 1 donut today. So that person brought in 1 donut. And so right now, if there was only 1 person in the classroom, that'd be fine, right? But now there's 10 people in the classroom. Okay, now that kind of sucks, right? Now let's say 1,000 people. So you're basically not even going to get anything of the donut anymore, are you? So you might get a sniff, and that's about it. So as we approach infinity, as we keep dividing it up bigger and bigger, that this is always going to go to 0. It's always going to go to 0. Now, since we're looking at the y values as x is approaching a number, that's important. I'm looking at the y values. So same thing goes if I'm going to negative infinity. My negative infinity here is going to look like this. So it's 1 over negative 1, 1 over negative 2, 1 over negative 4, 1 over negative 8. Again, it's the same thing, but now I just have an angry person I'm dividing by. I got, because they're negative 2 people, so they're angry, negative. Okay, all right, dang, all right. All right, so now we have just a bunch of negatives. But again, it is still being divided by the same thing. So even though that this is actually going to be negative numbers, my negative numbers, so if I'm looking at a little graph of this, so I'm looking at the graph, so as it's going, it's actually starting right here, and it's going closer and closer to 0 in that direction. So it's going to never really get to 0, but it's, as my x is going in, this is coming in from the negative side, so it's down here on the bottom, but it's still approaching 0. It's approaching my x-axis. So that one should be 0 in the end. Okay, either positive or negative, but it's still a 0. All right, same thing right there. Another rule, k and n are constants. We have x is, absolute value x is greater than 1. N is greater than 0. And again, for this, for any value that this n value is going to be greater than 0, that's squared, cube, positive numbers, right? So it doesn't matter what is it going to be. It's going to be the limit, which is going to be 1 over 0 eventually, right? So this limit right here, then times whatever k, because we're doing the limit part of this. So no matter what's that going to be, because the limit parts to goes to 0, anything times 0 is 0, right? So this whole thing right here comes out to be 0. So now, if we're looking at this piece right here, as this goes to infinity. Now, this is one of those key things that you have to be able to look at and identify, and I'm going to tell you the cheat for this. So, if they are the same degree, this is going 3 times infinity, the bottom goes 7 times infinity, but now it's infinity over infinity, right? So what it's happening is it's going to be in crap, man, my infinity is not very good. All right, infinity over infinity. So we're going to factor that out, and so if it's infinity over infinity, that's going to divide. So I'm going to be left with 3 over 7 because it's 3 times infinity over 7 times infinity. So if they're the same degree, this one's just going to give me 3 over 7. That works all the time if it's the same degree. Okay, super important, same degree. So here's the whole process to go along with that. Okay, here's the algebra on this. Yeah, there's algebra. You could work it out where by factoring it, you could end up getting just 3 over 7. It works out. As we go to infinity, we're going to get 3 over 7. All the time. So even if you did put in the calculator and start evaluating at huge numbers, it's still going to be 3 over 7.
All they did was divide by x.
Yes, because they wanted to cancel out the x in front. So cancel out the x in front. So multiply top and bottom by x, right? Or 1 over x. 1 over x. So that canceled out here. Cancel out here, so now I was able to put it over here. But we know the limit of this because we did that at the beginning, right? The limit of this is going to go to 0. The limit of this is going to go to 0, but then because I was able to cancel those out, it's going to be the limit of some constants.
That looks a lot complicated, but it's not.
Yeah. So that's why I'm just saying the process is easy. You know, you look at it, do they have the same degrees? Go for it. All right, so now, here's another one. Do these ones have the same degree? So, those leading coefficients are going to be what changes it. Because after we do the math and trying to set it up, so my leading term is like this. So this is going to give me 0, 0, 0, 0, my same degree, and I'm going to have 8 over 16. 8 over 16 just reduces to 1/2. Because they're the same degree. I just look at the coefficients in front. There's a whole lot of complicated math on it. I guarantee you, if it's the same degree. Now, different degrees. So if the top is bigger, that means that this is going to race to infinity that much faster. So since I'm looking at degrees, if the top is racing faster, that means this limit is not going to exist. Because it's eventually, the top is going to win a race. So if the top wins a race, it's going to start pulling it up more and more and more. If the bottom wins a race, that's dividing it by more and more. So top, so greater degree, E-A-T-E-R, yeah, greater degree. So greater degree, that means it goes to infinity, depending on the coefficient. If my coefficient was negative, that means this one right here would go to negative infinity, right? Negative infinity. So it's going to positive infinity because my leading terms are both positive. All right, so let's take a look. Higher, okay? And let's see, here's the bottom. So that means the bottom is racing faster. We're eventually going to get 0. That's always going to be true. So if the bottom has a greater degree, it's going to go to 0. Okay, now, limits of trig functions. This is an identity, and this is one that you have to know. If you see this at any point at all, you need to use this. This is going to simplify all your limits all the time. So whenever you see something like this, you're going to have to be like, okay, this I could use. So it's always going to give me 1. Okay, now there's another one. Let's see. Okay, so same strange, but of the graph of sine of x and f of x, they have approximately the same slope near the origin as x gets closer to 0, because x and the sine of x are about the same as x approaches 0. Their quotient will be closer to 1. Furthermore, because cosine, the limit of cosine is equal to 1. Okay, we know that tangent is going to be sine over cosine. Okay, it's going to be sine over cosine. So this is going to be 0. So again, consider this an identity. The tangent at 0 should give me 0. Now, can we just plug that in? Yeah. So tangent at 0. Let's see. Unit circle. My point right here. My coordinate right there, which would be 0 pi, is going to be 1, 0. And we know tangent is sine over cosine. Sine is 0. So that means that it's going to be 0 over, now cosine at 0 is going to be 1. 0 divided by 1 is just going to give me 0. So that does work out. Questions? Okay. All right, so here's another one. Cosine of x minus 1 over x is going to be 0. That's another one that we're going to treat as an identity. You will see that. I guarantee you will see this one on the test. You will see these on the AP exam. Because these are 2 things that you have to know from the limits. So if you were one of those people to be making like those little flashcards or whatever, I'm going to have some flashcards for you later on. Okay, you guys could actually go through with identities, and these are ones that you have to know. So whenever you just look at it, you pull it up, see it, know the answer. All right, so now this one right here. So if we were to do this, the whole rule to go along with this is that I need to have x over x. So whatever this value is here, it has to be the same down here. So I can multiply this. I can multiply by the value of 1. So that's going to be able to get this over here. So it's going to be sine of 3x over x. Is it warm in here or is it just me? No. Just me? Yeah. You guys are horrible. I think I'm going through menopause. Sweating all the time. All right, so as we multiply this out, that's going to give me my 3 times sine of 3x x over 3x. So now my 3 is just now down there. And so because I'm able to look at this and say, all right, 3x over 3x, this one right here, this whole piece right here is going to give me the value of 1. So all of that I circled is 1, now times 3, which is just going to give me 3 as my final answer. Questions? No? Good? All right, so now this next one, if you notice, right here is going to 0. Can I just plug in 0? No, I can't plug in 0, can I? I can't plug in 0. I can't plug in 0 because 4 times 0 is 0. Sine at 0 gives me undefined. Very good. So that's going to give me 0. So 0 in the denominator would be undefined. So that means I cannot do this problem as is. All right, so we know that if I turn it into, same thing on top and bottom like this, right? So for this case right here, I would multiply, on the bottom I would need what? A 5x, right? Okay, but now I'm going to rewrite this so I can look at it. So it's going to be sine of 5x over 1 all over sine of 4x over 1. So there's a couple ways of doing this, and I like this one. So I need a 5x for the top one, and I need a 4x on the bottom one. So what can I multiply by to still be able to actually have my value?
5 over 4.
I need it to be 1 though. Remember? To do this correctly, I need to have a value of 1.
It's like
20, all right? So it'd be 20x, right? So on top, I need 1 over 20x. But on bottom, so I'm looking at this now and I'm like, hey, I'm multiplying by the value of 1. It's the same on top and same on bottom, right? Okay, good. So same on top, same on bottom. So now for this one, I'm going to rewrite the top. So I'm going to rewrite it into 2 separate parts. So I'm going to have a 5x right here, right? And then it's going to be times 1 over 4. So 1 over 4 times sine of 5x over 5x. Now for the bottom, same idea, right? Same idea. So now I'm going to rewrite that as I need it over the 4x, right? Yes? Yeah? Maybe? Odie, you kind of have to have your eyes open to know what I'm talking about. Huh? Oh, I'm sorry. Do you want some coffee or something? I brought a coffee maker if you want that. Yeah, go ahead. All right. Listen, this is not a regular class. If you need to get up and think of this as a college class. If you need to get up, go use the restroom, go use the restroom. If you're struggling with something, you know what? Speak up. You know what? And I find hilarious that everyone sat in their assigned seats that you had on the first day, but no assigned seats anymore. So I find that hilarious. Anyway.
Where did the 1/4 come from?
1/4. Very good. All right. So now 4 times 5 gives me 20. I have 20x right here, don't I?
Oh.
So I broke it up just so I could have the 5x over 5x. Okay, so now you help me out. How am I going to write the next one? How am I going to write the bottom?
1/5
Come on. Times.
sine of 4x over 4x.
Very good. That's it, right? Yes? Good? No? Maybe? Okay, so now, we know that the sine of 4x over 4x is going to give me what as I take the limit?
1.
1. So this gives me 1. And this gives me 1 also, right? So both of those give me 1. So on top, I should have 1 over 4 divided by 1 over 5. But we can't have fractions over fractions. We multiply by the reciprocal of the bottom. So it's just going to be 1/4 times the reciprocal of the bottom, which is 5 over 1. So my total answer comes out to be 5 over 4. So a little bit different than if you're looking through the notes. How they did it, they did over x first and then went from there. Yeah.
So you're saying that sine 5x over 5x over sine 4x over 4x. So sine 5x over 5x is the same value as sine 4x over 4x?
Yes, as long as the values are the same. So the inside, the 5x over 5x, as long as those are the same, that's going to give me a limit of 1.
Couldn't we just do what we did for the infinity one, since it's still the same?
No. Yeah, this is going to 0, right?
Oh,
Then, yeah, it's going to 0. It's going to 0. So now, we're basically, it's going to be, was it 1 over 4 times the limit as x goes to 0 of sine of 5x over 5x, and 1/5 times limit as x goes to 0 of sine of 4x over 4x. So as long as these two items here match, that gives me 1. Same thing here. Okay? Even though that you have something weird there, that's going to give me 1. Good? Okay. All right. So, and so if there is some a of x right here, it's going to go to an a. Right? And limit right here, sine of b of x, it goes to b. So if you notice, just like that problem how we started off with, where did we start off with this? Here, right here. By doing all the math, then we come up with the shortcut, and we're like, okay, it's just 5 over 4, isn't it? And that's what we had. So as long as these are just some coefficient, so coefficient, as we take the limit, because we did the process using identity, we're going to get just 5 over 4. Now, for this next one, limit as x squared over 1 minus cosine x squared. So let's go through and actually do a couple things. Now, the trig identities, which a lot of people struggle with, is all the different things. So sine is x over, no, I'm sorry, y over is y over 1. Cosine is x over 1. Tangent is y over x. Cosecant is, that's going to be 1 over y. Secant is 1 over x, and cotangent is x over y. Now, these are from my unit circle. So it's whatever the y value is or whatever the x value is in my ordered pair of x's and y's. And then we have my Pythagorean identity, which is sine squared plus cosine equals 1. If you notice, I am not putting a variable in there, right? So as long as those variables match, this works. Because if this was a 2x and 2x, it would still give me 1. 5x and 5x, it would still give me 1. So whenever we do this, we're going to get here. So now, if you notice, I have a 1 minus cosine. I don't like that. 1 minus cosine. So I could actually turn this identity into 1 minus cosine. So by doing that, I would subtract cosine from both sides. So it would be sine squared is equal to 1 minus cosine squared. So being able to manipulate my Pythagorean identity over and over again, I get all my different identities. Just by subtracting it or doing whatever as necessary, it's always going to come out. So for this one right here, we're replacing it. So it's now the limit as x goes to 0. So x squared over sine squared x. Now, can I plug in 0 right away?
Yeah. I mean, wouldn't it be like a hole because
There's the 0 on the bottom, right? There's 0 on the bottom, it's undefined. I do not like it. Okay, I do not like 0 on the bottom. So that's a no. All right, so we're going to actually have to mess with this one right here to try and get it to be a little bit different. So what I'm going to do is I'm going to break it up into the two separate parts. So the two separate parts is going to give me my limit. So it's x over sine x times x over sine x. Right? So I know that with that identity, if it was sine x over x, that gives me 1, right? So that would give me 1 in the denominator. Yes? I'm going to make this into 1. I need to manipulate sine on the denominator to be over 1. So to do that, I'm going to multiply by something funky. What am I going to multiply by? Insert page. There we go. Okay, so we had sine there. Okay, so something funky. So that means I'm going to start off with it like this. I'm going to put what I need there and just clean up the rest. So I know I'm going to end up with x over 1 right here, and then sine x over 1. So I'm just expanding it for the point that I'm going to eventually get to. So I said I need this to say sine x over x, right? So that means on the bottom, I multiply by 1 over x. So that's going to dictate what I'm going to do for the rest of the time. So if I needed 1 over x on the bottom, what do I have to multiply by on the top? 1 over x, very good. So 1 over x. So I'm multiplying by a value of 1. So my 1 just looks funky. So it's same thing on top and bottom. It's still a value of 1. I'm just manipulating this to be the way I need it to be. So on top, what's going to happen? It's going to cancel out. So I'm going to be left with 1 over, now I have sine x over x. Now, at this point right here, I can take the limit as this goes to 0. So as this goes to 0, I know that the limit of the bottom is just going to give me 1, right? So doing the limit as x approaches 0, this gives me 1 over 1, right? So the bottom comes out to be 1. So now, again, I broke this up to be two separate, because my original problem was x squared over sine squared x. And the limit as x approaches 0. So now I broke it up into two separate limits right here. So over here, for those people on YouTube. All right, so I broke it up into two separate. So this right here gives me 1 times 1. So my whole answer is going to come out to just be 1. Hopefully that makes sense. All right, for this problem right here, what do we notice? Okay, can we plug in? Yeah, we could just plug in, right? Just plug in. So let's see, 3 minus 3 gives me 0. 3 plus 2 is 5. That just gives me 0. 0 is acceptable to have in the numerator. It is not acceptable to have it in the denominator. Okay, next one right here, as this goes to 3, so now 3 in the denominator, if I'm looking, gives me undefined, right? So as it goes undefined, now I have to actually start thinking about it. What's it going to do? So to figure this out, I know that because of this, I want to find limits on both sides. So this should be an easy test right here. So left hand and right hand of this. So on 3, let's go. If this is not a calculator portion, I would just, plug in, 2.999, enter, plug in the other side. So I know it's going to be, let's see, on top, I would plug in 2.9, right? So it would be 2.9 plus 2 over 2.9 minus 3. So on top, I want to end up getting 4.9. And on bottom, I get, okay, so it's going to be negative 0.1, right? Okay. So that is the left-hand side. So think about it. What is it happening every time as I do this? My number just keeps getting smaller and smaller and smaller, right? So if I were to plug in the next one, which would be 2.99 plus 2, and it would be 2.99 minus 3, that would give me 4.99 over negative 0.01. So as I get closer to my number, this is going to be a negative, isn't it? So the closer and closer I get to the number, what happens when I get a smaller and smaller number on the bottom? We know what happens on the bigger and bigger. Remember dividing it amongst more people, right? So think about it going backwards now. So if I'm dividing it, so I have the 1 over 16, everyone gets a really, really small piece, right? But now I'm dividing it by a smaller number, 1 over 4. So that pizza just went from 16 slices to 4 slices, right? So you get more of the pizza, right? So now it's going to be 2, right? That means as the denominator gets smaller and smaller and smaller, my whole value is getting bigger and bigger. So if I do this, the next one would be 1 over 1/2. Because this, I like this math on this one. So 1 over 1/2 would be the same as saying 1 times the reciprocal of the bottom, which is 2 over 1, which gives me 2. So as these numbers right here get smaller and smaller, my total value gets bigger. Okay? So this is going to go bigger and bigger and bigger. So that's why I'm saying this right here, as it's going smaller, it's going to go to bigger and bigger, right? So it's a positive over a negative. Positive over negative is going to give me negative. So this right here is going to be, actually let me just clear this off. So for this, it's going to be on top from the left-hand side. Let me see. Limit as x approaches 2.99, it gives me negative infinity. Now let's do the right-hand side. So if I was going to do the right-hand side, it's going to be the limit as x approaches 3.1. Let's see what that's going to be. So 3.1, so that would be 3.1 plus 2 over 3.1, and it's going to be minus 3. So from right here, the top part is going to give me 5.1, right? Yeah? 5.1. And the bottom part is going to give me positive 0.1. Okay? There's a reason why I'm doing this from left and right. So now if I were to do it again, okay, so it'd be 3.01 plus 2, 3.01 minus 3. That's going to give me 5.01 over a positive 0.01. So the left-hand side is going to negative infinity. The right-hand side is going to positive infinity. So this goes to positive infinity. So what do I know? Because this is going to negative, this is going to positive.
The limit at 3 does not exist.
Limit at 3 doesn't exist, right? So I can't say that both of them are going up to the same number, right? Yes? Okay. Let's see. Come on now. There we go. All right. Let me see. Let's. What problem is this? From 3. So we're going to go over to right here on the bottom. Practice. So we're going to do 15 minutes. So 15 minutes for snacks, drinks, restrooms, wake up, maybe make a coffee or something. So go ahead. So this is my first set right here. Like, share, and subscribe. And